All right, guys, this is the first of two lessons on distance time graphs. And so we're going to just quickly run through this. This is one where you're already given the distance time graph and you need to then do some calculations on it. It's pretty straightforward. But before we go ahead, there's one thing you need to remember. You need to remember that average speed is equal to distance over time. And some people like it better if they see it in a triangle. I particularly don't like the triangle because it doesn't teach you to do some proper algebraic movements, rearrangement, but it's a means to an end for quite a lot of people, so we're going to just use it just for today as well to help people out. So how you read this, it says average speed is distance on top of time. If I want to find out what, let's just say the distance is, block off distance, just literally block it off, and what you have left is speed next to time, which means speed by time. And if you want to find time, just block time off, and time is distance on top of speed. So that's the way you use it. All right, let's quickly talk about the graph we've got here. This is going to be our starting point, and this is going to be our time. This axis is going to be our time axis, which for now we'll have in hours. And this is going to be our distance axis, and for now we'll keep this in kilometers. Okay, all right, now what I want you to do is try and imagine this. How this graph actually works is like this. If you see a line like this, it's basically telling you time is being taken up, because as this line goes up, it's taking up time, but it's also taking up distance. And this line basically means that something is moving. So there's movement here. And this movement is away from the starting point. So it's moving away wherever, let's just say, I don't know, maybe this is home and I'm heading towards the shopping mall for a little bit, or whatever the case might be, or heading to a friend's house, say. So this is movement away from home. This bit here, what you notice is that the distance is stopped moving. It's not going up or down. It's just literally stuck at this point. But time waits for no man. Time still goes ahead. So time is still being taken up. And yes, you guessed it. This means that the object is stationary or not moving at all. But time is still going. So you can see time going there. And if you've guessed it already, this is a movement back to your starting point, or movement back home. Okay, so this is movement again. Okay, so that's our movement there. And that's basically the main thing you need to understand about distance time graph. So long as you know what's happening, you'll be fine. Now, let's hop straight into a question. So here I've got a partially drawn distance time graph. This is time in hours, and you can see after 2 hours, this is after 2 hours, whatever it is, has gone 50 kilometers. So this is distance in kilometers there. Okay, we'll keep that there for now. And I've marked off the key points that I want to focus on, so we'll talk about those in a second. Okay, right, so here we go then. We're going to calculate a few things, and let's just jump straight into it. So the few things we're going to calculate is, first of all, time spent stationary. I'll just put stat for that. Time spent stationary. Well, if you remember from what we've just done before, this part of the graph tells us that nothing is moving. This is, I probably should list this as my starting point here. Okay, so here something was moving, it stopped moving, and then it moved back, but it didn't go all the way to the starting point, so we'll need to be very careful. It looks like it stopped 10 kilometers away from the starting point. Anyway, time spent stationary. Well, it moved for 2 hours, it stopped there, and then it rested for a while. and then start moving after 5 hours. So basically you just need the distance, well, at the time between 2 and 5 hours. So that's 3 hours. So the time spent stationary is 3 hours. Okay. The next thing we'll look at is the speed when it was moving for the first time. Now, as I said before, speed is distance over time. So look at the first movement. This is the first movement here. The distance it traveled was from 0 all the way to 50. So that's the distance. So I'm going to put 50 over there, and that's my distance. I've just replaced the D with 50. And the time that it took to cover that distance is 2 hours. Yeah, 2 hours there. So I'm just going to put the time as 2. So this is the speed. Okay. And just a quick little bit of calculations, and you'll be able to say that this is 25 kilometers per hour. So that's the speed, 25 kilometers per hour for the first time. We can also find the speed for the second time if we wanted to. Speed is still distance over time. I'll just probably say that this is the first movement. And now we're going to find the speed for the second movement, okay? Now the second movement we can see is just this part here, all right? And let's see what actually happened in this one here. We started off at 50, we're moving back, but we stopped at 10. So the distance traveled between 50 and 10 is 40 kilometers. So that's going to be, my distance is going to be 40. And the time it took is just from that 5th hour to the 6th hour. So it's only 1 hour it took. So it looks like it was a much quicker journey back at 40 kilometers per hour. All right, so that's basically it. We can look for the total distance traveled, and that's an important one to pay attention to. Let's move this up slightly. Okay, the total distance traveled. Well, be very, very careful with this, if you will. It looks like whatever it was, it moved 50 kilometers, then rested, didn't go anywhere, then it came back another 40. So, yes, you probably guessed it by now. So, total distance will then be the 50 when you went for the first time, plus the 40 coming back, giving you 90 kilometers. It traveled in total. And the total time taken, if we wanted to, total time, well, that one, we can just read it off the graph because the total time it took is 6 hours there. So you can just read that off the graph, 6 hours. And last of all, we can find the average speed for the whole journey. It's still going to be distance over time, by the way, but this time I'm going to say this is for the whole journey. Okay, now average speed for the whole journey. Let's move this up a little bit. So average speed for the whole journey will give us the total distance traveled, which is 90 kilometers. A total time of 6 hours was taken. And so this means that it's going to be 15 kilometers per hour. Now, before I move on, you might be asking the question, well, hang on a minute. How could we include the time that there was no movement? But this is why this is called average speed, because you have to take into consideration all non-movement of the object or the person or whatever the case might be. So that's really important. That's why it's called average speed. It's not exact speed, it's average speed. Okay, right, one last question then. So here in our last question, we've got another graph. We've spaced things out just a little bit here on the time axis. This is still time in hours, and it looks like that goes up to 30. This across here will be 60. This will be 150 up here. All right, and this is going to be our distance in kilometers. All right, lovely. Let's get to work now. We'll do the exact same thing we did for the very first one that we just did. If you want, you can pause the video and have a go for yourself, see if you can make sense of it. But let's go. The first thing we're going to do, okay, let's define what we've got before we do anything else. It looks like something started up here. It didn't start at the starting point down here. It started up here. It was moving towards the starting point, then it stopped, then rested, then it started going away from the starting point. Okay, so we're going to do, first of all, speed is distance over time, but this is the speed in the first movement. Okay, so we're only looking at the speed just for this first bit here. All right, let's go. Well, it's still distance over time, and as you can see, the distance traveled was from all the way up here to all the way down there, stopping on 30. So if you look for the distance between 30 and 150, you'll find out that that's going to be 120. So we're going to have 120, and the time that it took to complete that speed, because we still need time, the time it took to complete that speed, that distance, is an hour and a half, because there's an hour there and then another half an hour there. Or you can say 1 hour and 30 minutes, but I'm not going to put 1 hour and 30 minutes because time needs to be in hours. So we're going to say that it's going to be 1.5 hours. Okay. And that's going to give us 80 kilometers per hour. Okay, so that's where we got with that. All right, the next thing we're going to calculate again, same as we did in the last one. So that's the speed for the first time. The time spent stationary. So time stationary. And as you remember from the first thing I explained here, distance is not moving up or down, but time is still moving, and it looks like it started an hour and a half after the journey it started, and it ended 2.5 hours after. So that's basically been stationary for 1 hour. Okay, then we're going to do the speed again, which is distance over time, but the speed in the second movement. So the speed in the second movement. So we're basically concerned with just this last bit here. Well, like I said, speed is still distance over time. Let's check the distance. It looks like it started on 30 and stopped on 60. So the distance it's covered is only a distance of 30. So that's going to go 30 kilometers. And it looks like the time that it took is from that 2.5 to 3 hours bit there. So it's only taken half an hour. And for that one, I'm going to put 0.5 or half an hour. Okay, when you work that out, that should give you 60 kilometers per hour. All right, so that's the speed in the second bit. And then we can go and do the total time taken and the total distance traveled, and so on, and the average speed for the whole journey. So I'm just going to jump straight to that bit then, and I'm going to do the average speed for the whole journey. Speed is distance over time, and this is for the whole journey. All right, so let's go then. Now, to get the speed for the whole journey, I need the total speed, the total distance that was traveled. Well, it traveled down here 120, and then after that, it went up back another 30. So the total distance traveled, if you add those two together, is going to be 150 kilometers. And the time it took altogether, 0 to 3 hours. So that's going to be 3 hours there that it took, which will then give us 50 kilometers per hour. All right, guys, so that's basically it. That's my first video on distance time graph. I'll do a second video where you're given information and you need to draw the graph. I hope this was enjoyable. Show your love by liking the video. All right, thank you.